National Electrical Code, or NEC, Section 110.14 pertains to the electrical continuity of metal raceways and enclosures. It stipulates that electrical continuity must be secured without relying upon joints or fittings to maintain continuity. Regarding the connection of different ampacity-rated buses within a switchboard, the NEC does not explicitly address this scenario. However, the general requirement for electrical continuity outlined in NEC Section 110.14 implies that the connection must be made in a manner that maintains the ampacity of the system. Industry practice reveals that it is not uncommon for switchboard manufacturers to reduce the ampacity of buses within a switchboard, both horizontally and vertically. This practice is often employed to accommodate the physical constraints imposed by the switchboard enclosure. When reducing the ampacity of a bus, manufacturers typically employ a tapered or step transition to gradually decrease the cross-sectional area of the bus. This technique helps to minimize the potential for overheating at the connection point. Considering a specific scenario, connecting a 2000 amps rated copper bus to an existing 1600 amps rated copper bus would be permissible, provided that the connection adheres to the manufacturer's instructions and the following conditions are met. Firstly, the connection is made using a tapered or step transition. Secondly, the connection is made with a minimum of 3 bolts. Thirdly, the bolts are torqued to the manufacturer's specified torque value. In addition to the NEC requirements, several other factors warrant consideration when connecting buses of different ampacity ratings. Firstly, the potential for overheating at the connection point. Secondly, the voltage drop across the connection point. Thirdly, the potential for arcing at the connection point. In conclusion, the NEC does not explicitly prohibit the connection of different ampacity rated buses within a switchboard. Nevertheless, the overarching requirement for electrical continuity necessitates that the connection be executed in a way that preserves the ampacity of the system. Furthermore, industry practice lends support to the utilization of tapered or step transitions to reduce the ampacity of buses within a switchboard. When connecting bus bars of different ampacities within a switchboard, several crucial elements need careful attention to ensure safety and code compliance. The National Electrical Code provides general guidelines, but specific applications often require engineering judgment and adherence to manufacturer specifications. Firstly, NEC Article 110.14, as mentioned, emphasizes the importance of maintaining electrical continuity. This means the connection between the 2000 amps and 1600 amps bus bars must not compromise the overall current carrying capacity or create excessive heat. The connection should be robust and reliable, minimizing the risk of failure under load. Secondly, the physical connection method is critical. A tapered or step transition, as highlighted, is a common industry practice. This gradual reduction in cross-sectional area helps to distribute current flow evenly, preventing localized hotspots. The design of this transition should be carefully engineered, considering factors such as current density, material conductivity, and heat dissipation. Thirdly, the number and torque of bolts used in the connection are vital for maintaining adequate pressure and contact area between the bus bars. Using a minimum of 3 bolts, as suggested, provides redundancy and ensures a secure connection. The bolts must be torqued to the manufacturer's specified value to achieve the optimal clamping force. Over-tightening can damage the bus bars or bolts, while under-tightening can lead to loose connections and increased resistance. Fourthly, material compatibility is essential. Since both bus bars are copper, the risk of galvanic corrosion is minimized. However, if dissimilar metals were involved, appropriate measures, such as using joint compounds or isolating materials, would be necessary to prevent corrosion and maintain conductivity. Fifthly, heat dissipation is a primary concern. The connection point is a potential source of heat generation due to increased resistance and current density. Adequate ventilation and cooling may be required to prevent overheating and ensure the longevity of the switchboard components. Thermal imaging can be used to monitor the temperature of the connection under load and identify any potential hotspots. Sixthly, voltage drop across the connection should be minimized to maintain system performance. Excessive voltage drop can lead to reduced equipment efficiency and malfunction. The connection should be designed to have low resistance and minimal impedance. Seventhly, arcing is a significant safety hazard. Loose connections or corroded surfaces can create high resistance points that lead to arcing. Arcing can damage equipment, cause fires, and pose a risk of electric shock. Regular inspection and maintenance are crucial to prevent arcing. Eighthly, manufacturer's instructions should always be followed. Switchboard manufacturers typically provide detailed instructions for connecting busbars, including torque specifications, connection methods, and recommended hardware. Deviating from these instructions can void the warranty and compromise the safety and reliability of the equipment. Ninthly, relevant industry standards, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, and the National Electrical Manufacturers Association, or NEMA, provide valuable guidance on switchboard design and installation. These standards cover topics such as busbar sizing, connection methods, and testing procedures. Tenthly, proper documentation is essential. Detailed records should be kept of all connections, including torque values, materials used, and inspection dates. This documentation is crucial for future maintenance and troubleshooting. It's also important to consider the specific application and load characteristics when connecting busbars of different ampacities. If the load is continuous and close to the rated ampacity of the 1600 amps busbar, it may be necessary to upgrade the busbar to a higher ampacity to ensure adequate capacity and prevent overheating. The National Electrical Code, or NEC, offers some flexibility in interpreting and applying its rules, but it's always best to err on the side of caution and consult with a qualified electrical engineer to ensure compliance and safety. The engineer can perform calculations to verify that the connection is adequately sized for the intended load and that it meets all applicable code requirements. One crucial aspect is the cross-sectional area of the busbars and the connecting hardware. The cross-sectional area must be sufficient to carry the intended current without exceeding the allowable temperature rise. NEC Table 310.15b16 provides ampacity ratings for conductors based on their size, insulation type, and ambient temperature. While these tables are primarily intended for conductors, they can also be used as a guide for sizing busbars. However, it's important to consider the specific characteristics of busbars, such as their shape, material, and cooling method, when determining their ampacity. Another important consideration is the short-circuit current rating of the switchboard. The busbars and connecting hardware must be able to withstand the forces and thermal stresses generated during a short-circuit event. The short-circuit current rating is typically specified by the switchboard manufacturer and should be verified to ensure that it meets the requirements of the installation. The connection between the 2000 amps and 1600 amps busbar should be designed to minimize the impedance of the circuit. Impedance is the opposition to the flow of alternating current and is composed of resistance and reactance. High impedance can lead to voltage drop, reduced equipment efficiency, and increased heating. The connection should be made as short and direct as possible, and the conductors should be properly sized to minimize resistance. Reactance can be minimized by using closely spaced conductors and avoiding sharp bends. In addition to the physical connection, it's also important to consider the control and protection of the circuit. The circuit should be protected by appropriately sized overcurrent devices, such as circuit breakers or fuses. These devices should be coordinated to provide selective tripping, meaning that the device closest to the fault should trip first, minimizing the disruption to the rest of the system. The control system should also include features such as metering and monitoring to allow for accurate measurement of current, voltage, and power. This information can be used to optimize system performance and identify potential problems before they lead to failures. Regular maintenance is essential for ensuring the long-term reliability of the busbar connection. Maintenance should include visual inspections for signs of corrosion, overheating, or loose connections. Torque values should be checked and adjusted as needed. Thermal imaging can be used to identify hotspots that may indicate a problem. The switchboard should also be cleaned regularly to remove dust and debris that can contribute to overheating. In some cases, it may be necessary to apply a protective coating to the busbars to prevent corrosion. A coating should be compatible with the busbar material and should be applied in accordance with the manufacturer's instructions. If the busbar connection is exposed to moisture or corrosive environments, it may be necessary to use a sealed enclosure to protect the connection from the elements. The enclosure should be designed to prevent the ingress of moisture and corrosive substances. The enclosure should also be properly grounded to provide a path for fault current. When working on electrical equipment, it's essential to follow safe work practices. Always to energize the equipment before working on it, and use lockout/tagout procedures to prevent accidental energization. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. Be aware of the potential hazards of electricity and take steps to mitigate those hazards. The National Electrical Code, or NEC, is a comprehensive set of rules and regulations governing the safe installation of electrical equipment. It's important to be familiar with the NEC and to follow its requirements when working on electrical systems. The NEC is updated every 3 years, so it's important to stay current with the latest edition. In addition to the NEC, there may be local codes and regulations that apply to electrical installations. It's important to be aware of these local requirements and to follow them. Consulting with a qualified electrical inspector can help ensure that your electrical installation meets all applicable code requirements. The connection of busbars of different ampacities within a switchboard is a complex task that requires careful planning, design, and execution. By following the guidelines outlined in this discussion and consulting with qualified professionals, you can ensure that the connection is safe, reliable, and compliant with all applicable codes and standards. Remember to prioritize safety and to take all necessary precautions to prevent electrical shock or other hazards. Also, be sure to document all work performed and to keep accurate records of all materials used and procedures followed. This documentation will be invaluable for future maintenance and troubleshooting. Consider the ambient temperature and ventilation around the switchboard. High ambient temperatures can reduce the ampacity of the busbars, while inadequate ventilation can lead to overheating. Ensure that the switchboard is located in a well-ventilated area and that the ambient temperature is within the manufacturer's specifications. Regularly inspect the switchboard for signs of overheating, such as discoloration or melting of insulation. If you observe any signs of overheating, take immediate action to correct the problem. This may involve reducing the load on the circuit, improving ventilation, or replacing damaged components. In some cases, it may be necessary to derate the busbars to account for the high ambient temperature. Derating involves reducing the allowable current carrying capacity of the busbars to prevent overheating. The amount of derating required will depend on the ambient temperature and the type of busbar. Consult the manufacturer's specifications for guidance on derating. Ensure that the switchboard is properly grounded to provide a path for fault current. A properly grounded switchboard will help to protect personnel from electrical shock and to prevent damage to equipment. The grounding system should be inspected regularly to ensure that it is in good condition. Check the tightness of all grounding connections and ensure that the grounding conductors are properly sized. If the switchboard is located in an area where there is a risk of lightning strikes, consider installing a lightning protection system. A lightning protection system will help to protect the switchboard from damage caused by lightning strikes. The lightning protection system should be installed in accordance with applicable codes and standards. The busbar connection should be designed to minimize the risk of vibration. Vibration can loosen connections and lead to overheating. If the switchboard is located in an area where there is significant vibration, consider using vibration dampening materials to protect the busbar connection. Regularly inspect the busbar connection for signs of looseness. If you observe any signs of looseness, tighten the connections immediately. Use a calibrated torque wrench to ensure that the connections are tightened to the proper torque value. When connecting busbars of different ampacities, it's important to use appropriate connectors. The connectors should be sized to match the ampacity of the busbars and should be made of a material that is compatible with the busbar material. Use connectors that are specifically designed for connecting busbars of different ampacities. These connectors typically have a tapered or step designed to provide a smooth transition between the different busbar sizes. Avoid using makeshift connectors or adapters, as these can be unreliable and can create a fire hazard. The connectors should be installed in accordance with the manufacturer's instructions. Ensure that the connectors are properly tightened and that they are making good electrical contact with the bus bars. Regularly inspect the connectors for signs of corrosion or damage. If you observe any signs of corrosion or damage, replace the connectors immediately. The busbar connection should be protected from physical damage. Physical damage can compromise the integrity of the connection and can lead to overheating or electrical shock. Locate the switchboard in an area where it is not likely to be struck by moving equipment or other objects. Provide barriers or guards to protect the busbar connection from physical damage. Regularly inspect the busbar connection for signs of physical damage. If you observe any signs of physical damage, repair or replace the damaged components immediately. Ensure that the switchboard is properly labeled. The label should clearly identify the voltage, current, and other important information about the switchboard. The label should be legible and durable. The labels should be installed in a location where they are easily visible. The label should comply with all applicable codes and standards. Train personnel on the proper operation and maintenance of the switchboard. Personnel should be familiar with the hazards associated with electricity and should be trained on how to safely operate and maintain the switchboard. Personnel should be trained on how to identify and respond to potential problems. Personnel should be provided with appropriate personal protective equipment. The training program should be documented and should be updated regularly. Keep a log of all maintenance activities performed on the switchboard. The log should include the date, time, and description of the work performed. The log should also include the names of the personnel who performed the work. The log should be kept in a safe and accessible location. The log should be reviewed regularly to identify any trends or patterns. By following these guidelines, you can help to ensure that the connection of busbars of different ampacities within a switchboard is safe, reliable, and compliant with all applicable codes and standards. It is crucial to remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician or electrical engineer if you have any questions or concerns. Moreover, switchboard manufacturers often have specific recommendations or requirements for connecting busbars of different ampacities in their equipment. Always consult the manufacturer's documentation and follow their instructions carefully. This can help ensure that the connection is made properly and that the switchboard operates safely and reliably. If there are any discrepancies between the manufacturer's instructions and the general guidelines provided in this response, always follow the manufacturer's instructions. They are the experts on their equipment and their recommendations should take precedence. Regular inspections are key to maintaining the safety and reliability of any electrical installation, including switchboards with connections between busbars of different ampacities. Inspections should be performed by qualified personnel who are trained to identify potential problems. The frequency of inspections will depend on the environment in which the switchboard is located and the type of load it serves. Switchboards in harsh environments or those serving critical loads may require more frequent inspections. During an inspection, pay close attention to the following items. Firstly, signs of overheating such as discoloration or melting of insulation. Secondly, loose connections indicated by vibration or buzzing sounds. Thirdly, corrosion or damage to busbars, connectors, or other components. Fourthly, proper grounding and bonding. Fifthly, adequate ventilation and clearance around the switchboard. Sixthly, proper labeling and signage. Seventhly, any unusual odors or sounds. If any problems are found during an inspection, take immediate action to correct them. This may involve tightening connections, replacing damaged components, cleaning the switchboard, or improving ventilation. Document all inspection findings and corrective actions taken. Remember that electrical safety is paramount. Always follow safe work practices and use appropriate personal protective equipment when working on or near electrical equipment. If you are not qualified to perform electrical work, hire a licensed electrician to do the job. In addition to the technical considerations discussed above, it is also important to consider the administrative and regulatory aspects of connecting busbars of different ampacities in a switchboard. Ensure that all work is performed in accordance with applicable codes and regulations. Obtain any necessary permits or approvals before starting work. Use qualified personnel to perform the work. Maintain accurate records of all work performed. By addressing both the technical and administrative aspects of the project, you can help ensure that the connection is safe, reliable, and compliant with all applicable requirements.